the same
Alright,
types
so
of
you guys
things.
think you're good enough to deal with that
Combining
skipjack in the
zeros to get
system?
zeros.
We went from here to here.
Combining
And I'm not going to give you any of these
negative
X's at all. You don't know
and a
well, who's
negative
who
with a
around
negative
here.
weight, which makes a positive, to get a zero.
You don't know what's down there, is it?
And here we have
I just see
combining two
fuzzies and
negatives
squigglies
to
down
get a
there,
negative.
Bob.
So again, you'll notice the
Gunslinger, I don't
receptive
wanna hear
field
any
of
shit,
this
you
is
put it on
exactly
target.
the inverse of our input. So it makes sense that its weight would be negative, or its value would be negative.
Before I got here, I knew there was issues. If you really want
And
to
we
get
move
to
to
the
the next
neural
layer.
net and summon GPT-3
All of these, of course,
into
these
this
zeros
region of
propagate
the universe,
forward.
you're going to have to do some things on
Here,
the optics of this
this
thing
is
going
a
on.
negative, has a negative value, and it has a positive weight. So it just moves straight forward.
So we
because
stopped
we have a
at the banana.
rectified linear unit.
Most commonly,
negative values
rocks or
become
a fist
zero.
fight.
So now it is zero again
Off
too.
wherever
But this
the
one
hell
gets
this
rectified
was.
and becomes positive.
Then it clinks up
Negative
in its
times
position.
negative is positive.
Does the thing. Clink, clink,
And
clink,
so when
clink,
we
clink.
finally get to the output,
And I change over my process.
you can see they're all zero except for this horizontal, which is positive. And that's the answer. Our neural network said this is an image of a horizontal line.
I hold them, you hit them.
Now, neural networks usually aren't that good, not that clean. So there's a notion of, with an
Pen and
input,
blood,
what is truth?
carved in stone.
In this case, the truth is this
people
has a
died for
zero
this,
for
we buried
all
a
of
bunch of
these values, but a 1 for
Some with
horizontal.
headstones,
It's
some
not
without.
solid, it's not vertical, it's not diagonal. Yes, it is horizontal. An arbitrary
The truth
neural
matter
network
is, you
will
granny
give
want to take you out with
answers
the
that are
Marines,
not
because I don't know who
exactly
you are. We're
truth. You might
talking
be
to
off
an
by a little
arbitrary person.
or a
She's going
lot.
to cry for you. Your family might be
And then
pissed
the
at the system
error
for a little while.
is the magnitude
But in
of the
accordance
difference
to the rules
between
on
the
the
truth
Supreme
and
Court
the answer
case,
given. And
General
you can add all
Brown
these
law
up to
him
get the
away.
total error
This is how this
for the
will
neural
go.
network.
And if I got that wrong, I'm going to come in there and beat the shit out of
the
you,
idea,
GPT-3.
the whole idea with learning and training is to adjust the weights
Fake right here.
to make the error as low as possible.
I think I'm Jordan, and you would
So
be
the
right.
way this is done
But so
is
wrong.
we put an image in, we calculate the
Weird.
error at the end, then we
Put a
look
little
for
sign
how
right
to
here, and
adjust
I'm going
those
to plant my
weights
flag and
higher
you're
or
at the
lower.
bottom, because that's easy
Either
enough to
make
see.
that error
You're
go
not
up
at the bottom, you're moving to it,
down.
though, pretty quick.
And we, of
in
course,
this angle.
adjust the weights in the way, then make the error go down. Now, the problem with doing this is each time we go back and calculate the error, we have to multiply all of those weights by all of the neuron
DNR.
values at each layer. And we have to do that again and again once for each weight.
Only if that changes.
This takes forever.
As of the moment,
in
GPT-3 looking
computing
at
terms,
DNR, and we
on
create him and throw
computing
him in the
scale.
river.
And so it's not a practical way to train a big neural network.
We can get out some of them videos.
can imagine,
or something.
instead of just-
make them all watch a fucking Lodge video or something. You dumb motherfucker.
Rolling down to the bottom of a simple valley, we have a very high dimensional valley, and we
Yeah,
have to
you don't
find
feel
our
it.
way down. And because there are so many dimensions, one for each of these weights, that the computation just becomes prohibitively expensive.
Telling you, Paris Island rolling here. All of a sudden, you're
Luckily,
like, what did we
there
do
was an
wrong? You
insight
don't even
that
understand.
lets us do this in a very reasonable time. And that's that if we're careful about how we design our neural
Okay, keep
network,
it that way.
we can
You slow it, don't
calculate
be
the
lost.
slope directly, the gradient. We
Zero
can
missing
figure out the
instructions,
direction that we
couple of
need
L
to adjust
brackets.
the weight without going all the way back through our neural network and recalculating.
Bring in the flat bars and the crowbar and the brother with the stick. And
So, just to review,
Gets it done.
the slope that we're talking about is when we make a change in weight, the error will change a little bit. And that
what was
relation of the
knee,
change in weight
crotchety,
to the
and
change in
salty as
error
fuck.
is the slope. Mathematically, there are several ways to write this. We'll favor the one on the bottom. It's technically most correct. We'll call it DEDW for shorthand.
X, Y,
Every time
Z, T,
you see
A, B,
it,
C,
just
T,
think the change in error
I,
when I
T,
change a weight,
J, Z,
or the change in the thing
T,
on the top
whatever.
when
T
I
again.
change the
Sure,
thing on the
I
bottom.
go T again. Why not?
This does get into a little bit of calculus. We do take derivatives. That's how we
You up
calculate
this morning?
slope.
You
If
good?
it's new to you, I strongly recommend a good semester of calculus, just because the concepts are so universal.
Puts them on top though.
And
I give him
a
big
lot of them
Venom
have very
card,
nice physical
Matthew on the
interpretations,
right
which I
about
find very
Marshmallow being a fucking dragon.
But
so.
don't worry. Otherwise, just gloss over this and pay attention to the rest, and you'll get a general sense.
Gravity
of how
is
this works.
good. You believe that shit? You wrote.
So in this case, if we change the weight by +1, the error changes by -2, which gives us a slope of -2. that tells us the direction that we should adjust our weight and how much we should adjust it to bring the error down. Now, to do this, you have to know what your error function is. So assume we had an error function that was the square
This is your error
weight.
function. I'm going to need a name on your list.
See that our
Let's
weight
start to do this
is
different
right at
for
minus
everybody.
1. So the first thing we do is we take the derivative, change in error, divided by change in weight, dE dW. The derivative of weight squared is 2 times the weight. And so we plug in our weight of minus 1, and we get a slope, dE dW, of minus 2. Now, the other trick that lets us do this with deep neural networks is chaining. And to show you how this works, imagine a very simple, trivial neural network with just one hidden layer, one input layer,
and you
one
want to
output
succeed.
layer,
You
and
want
one weight connecting each of them. So it's obvious to see that the value y is just the value x times the weight connecting them, W1.
Everybody here.
So if we change W1 a little bit,
right now,
we just take the derivative of y with respect to W1, and we get x. The slope is x. If I change W1 by a little bit, then y will change by x times the size of my adjustment.
They're not carnies anymore. They're fair guys because it's
Similarly,
just
for the
gravity's
next
good.
step, you can
It's
see
gonna
that
fucking wreck you. I mean, it
just the
gets
value
nasty
y
out there
times the weight
byproduct.
W2.
Doing gravity, but
So
not
when
to
we
the right
calculate
numbers.
dE dy, it's
You
just
undersell
W2.
it, then oversell it, right? And freedoms and stuff.
Because this network is so
comes
simple,
in, you see
we
it
can calculate
nowadays
from one
with
end
what
to
it
the
is.
other.
On the over
X
extremities of the
times
low ends of the
W1
bunnies.
times W2 is the error.
It's a day bunny.
And so if we want to
Rabbit
calculate
draw.
how much will the
Tax
error
that.
change if I
Fucking
change
drop. That's
W1,
your number.
we
That's
just
my
take the
money. That's your
derivative of
money.
that with respect to W1 and get X times W2. So this illustrates, you can see here now, that what we just calculated is actually the product of our first derivative that we took, the dy dw1, times the derivative for the next step.
I got his numbers in the stone mill right here. You
together.
gonna take that anomaly guy over there at the...
This is
You
chaining.
can take his numbers in mine.
You can calculate the slope of each tiny step and then multiply all of those together
blowing it up. I'm
to
sure
get
good.
the slope
We need to
of the
prove
full
naps
chain.
and all the money we put in
Derivative
shit
of the
because you
full
guys
chain.
got a loud mouth and like to fucking
So in
get
a
out there.
deeper
Eric
neural
Click one
network,
figured out
what this would
when he
look
whipped
like
it out and put it in your
is
mouth.
if
Told
I
you
want
to
to know
shut
how
it.
much the error will change if I adjust a weight that's deep in the network, I just calculate the derivative of each tiny little step
They got it
all
right.
the way back to the weight that I'm trying to calculate, and then multiply them all together. This computationally is many, many times cheaper
in the mirror, buddy.
than what we had to do before of recalculating the error for the whole neural network for every weight.
Good. Should be on video.
Now, in the neural network that we've created, there are several types of backpropagation we have to do. There's several operations we have to do.
He should definitely know how to do
each
physics
one of
engine. It's like,
those,
no, buddy.
We have to be
This
able
is
to
you.
calculate this.
Ding, Atomos.
So for the first one is just a weighted connection between two neurons, A and B.
Help you out, buddy.
So
get them watching
let's assume we know
that
the change in
Shining
error with
video, or
respect
the
to B.
Ready Player One. I want you to be the butler,
know
dude.
the
You
change
hit the
in
bell,
error with
you're right
respect
there
to
for
A.
him. Kill him
To
kind.
get there,
Take him down.
we need to know dB dA. So to
Does
get
it
that,
like
we just
that?
write
Or is he
the
just looking at me
relationship
right now?
between B and A.
Blink.
Take the derivative of B with respect to
scroller
A,
anyway.
we get the weight, W, and now we know how to make that step. We know how to do that little nugget of backpropagation.
So you all take as much as
Another
you need
element
until
that we've
there's
seen
numbers left, and when it
is
comes to it, I'll
sums.
just keep taking
All of our
and throwing it in mine, and
neurons
then
sum
you
up a
can-
lot of inputs. To take this backpropagation step, we do the same thing. We write our expression,
It should be. That's why I like
and then
Uncle
we
Sam.
take the derivative of our endpoint, Z, with respect to our step that we're
Because I'll step
propagating
him in
to
here,
A,
big dog. Hydrogen number one
DZDA
supreme
in
all.
this case is
Kill
just
us all
one.
before you will bleed out.
which makes sense. If we have a sum of a whole bunch of elements, we increase one of those elements by 1, we expect the sum to increase by 1. That's the definition of a
Let me
slope
show you what I
of
mean.
1.
with Elon.
One-to-one relation there. Another element that we have that we need to be able to backpropagate
Why do you
is
do
the
that to
sigmoid
them?
function.
Because they're comfortable sitting there
So this
enjoying
one's a
themselves.
little bit more
They don't
interesting
understand the
mathematically.
apocalypse out there.
We'll just write it shorthand
is.
like this, the sigma function. it is entirely feasible to go through and take the derivative of this analytically and calculate it. It just so happens that this function has a nice property.
Luckily, I didn't have a master telling me.
To get its derivative, you just multiply it by 1 minus itself. So this is very straightforward.
I say carry one without a G or with a G, depending on how you like to juggle it.
Another element that we've used is the rectified linear unit.
Get them to the left.
Again,
you gotta,
figure out how to
focus on that.
backpropagate
When you
this.
walk a straight line, you
Write
gotta
out
pull
the
to the left
relation.
a little bit.
B is equal to A if A is positive, otherwise it's 0. And piecewise, for each of those, we take the derivative. So dB dA is either 1 if A is positive, or 0. And so with all of these little backpropagation steps and the ability to chain them together, we can calculate the effect of adjusting any given weight.
There. It's like they did it all for these numbers. They really only needed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. A through Z on the basic infrastructure. Why A through Z though? Why not A through T?
So
well, it is.
Assign them all random values.
A, B, C, D, E, F, G, H, I, J, K, L, M, N, N, O, P, and I can stop that program right there.
We know the answer to.
The answer is
know whether it's
going to be
solid, vertical, diagonal, or
right
horizontal. So
and this
we
little
know what truth should be.
Changing shape, blinking
so
at
we
you,
can
doing
calculate
stuff.
the error. Then
computer chips,
we run it through,
4-bit
calculate
5x5 chip.
And using
because then it's a
backpropagation,
resistor, a capacitor.
go through
it's got 2 pins. It kind of
those
comes in,
weights
does things.
tiny
4
bit
pins,
in the right
5
direction.
pins, 6 pins. You know,
and then we
there's
do that
clock,
again with
it's
another
4 pin.
input.
Gotta
Again
have
with
either
another
of
input.
those to do things in
If we can
organizations
get
and
away
what
with
those
it,
things neural net
many
into
thousands or
by
even millions
Y
of
letters.
times.
Well, it's not that you
And
can't do it
eventually, all of
arbitrarily
those
on
weights
this prime
will
or
gravitate,
figuring out a new
they'll
symbol.
roll
Let's
down
Cthulhu's
that
damn click
many-dimensional
inside here.
valley
Oh, it's got to be
to a
that
nice
shape,
low
and
spot
only then will it
bottom,
ever allow you to
where
let it
performs
draw.
really well and does pretty close to truth on most of the images.
Different. Same thing though. Why?
If we're really lucky,
it did
it'll look like what we started
blink, click
with
button.
intuitively
right the page. Right
understandable
Entropy.
Receptive fields for those neurons, and a relatively sparse representation, meaning that
Solid,
most of the
vertical,
weights
diagonal,
are
horizontal,
small or close to 0.
size,
It doesn't always turn out that way, but
well,
what
this is
we
an
are
XYZ.
guaranteed
Solid.
is that it'll find a pretty good
it's got some fuzz. I'm
representation
just
of
see a blue
the
background.
best
Could
that
be
it can
correlated
do,
to anything. Is
adjusting
it
those
because it's what's
weights
up, vertical,
to get as
up and
close as
down,
possible to the right
diagonal,
answer
this
for
way
all
across?
of
Got the
these.
X, Y, and Z on Lorenzo's for the horizontal. Got the angle on this thing to the
So
wind.
what we've covered is just a very
line.
basic introduction to
Square
the
way.
principles behind neural networks. I haven't told you quite enough to be able to go out and build one of your own, but if you're feeling motivated to do so, I highly encourage it. Here are a few resources that you'll find useful. You'll want to go and learn about bias neurons. Dropout is a useful training tool. There are several resources available from Andrei Karpathy, who is an expert in neural networks.
It kind of winds up being, no matter what you do from
great
here,
at teaching about it.
you're going to be fucked.
Also, there's a fantastic article called The Black Magic of Deep Learning that just has a bunch of practical from the trenches tips on how to get them working well. If you found this useful, I highly encourage you
on the Demon
to visit
Core,
my blog
needs to look
and check out several other How It Works style posts. And the links for these slides you can get as well to use however you like. There's also a link to them down in the comments section.
How the devil would do it. I mean, like,
Thanks
sign
for
a
listening.
contract. I'm good here. All right.